Hi everyone, I'll be going through the IA briefing video with you. Similar to the cohort, you will be able to access this IA briefing video, but I was thinking that I will just bring you through is clearer. Okay, so in the briefing, it will cover the IA timeline, things like collaborative work, some of the flow of processes. Okay, initially I want to use this video, but because it's a little bit small, so what I will do is that I will be referring more to this document, and this document will also be Teams out to you. Okay, so it's bigger, so you can take a look at the screen better. So for the IA data collection, the whole cohort is divided into two groups. So 5.5, you will be in group A, and the SL classes, you will be in group B. So let's look at the IA timeline. Let's look at group A first. So for group A, now this is week 7, and come week 8 Friday, you will have to submit your IA proposal to me, and that is around 15 or 16 of May. Okay, 15 of May, roughly about 15 of May, you will submit your proposal. And that is about week 8. So week 9, I will be able to get back to you, and over week 9 and week 10 get back to you so that we can firm up your topic and you can submit your chemical requisition by week 10. That is for classes in group A. Okay, and that is 5.5. So you will then come term 3 week 1 will be starting your data collection in the lab, starts from week 1 all the way until around week 7. And you have to finish your data collection by then. Okay, then after that, you'll focus and then go prepare for your promotional exam. Immediately after promotional exam, you will work very hard to write your IA draft because you need to submit the draft by week 6. And IB only allows for one draft, so that one draft will be submitted in week 6. Okay, now before I go on further, take note that this IA for IB, for chemistry, we only have one IA. We have only one IA, and that's 20% of your IB scores. So therefore, you have to do it well. For group B, the SL classes, you'll find that you have a little bit more time in order for you to get out the proposal. I would suggest submitting the proposal to me about week 6. Okay, by week 6 of term 3, your proposal has to be in so that I can spend again 2 weeks in class with you to go through your proposal and work so you can touch up on your proposal such that before around week 9, you will be able to submit your requisition to the lab. So by week 9, you will submit to the lab what are the chemicals that you need and so on. So I need to clarify, when we say submit requisition to the lab, doesn't mean that whatever you request, the lab will prepare for you. It's just to make sure that what you want is available. Okay, eventually, all the chemicals will be prepared by yourself. You have to do it. Or later, I will bring you through that. So the chemical requisition and the equipment requisition part is more to double check that the things that you want is available in the lab and you're not doing something too dangerous. So then after that, you focus on your promotional exam for the group B, which is after your exam, immediately after exam, you will collect your data in the lab. And because post-promo, we will have some normal regular lessons days. So you will use those regular lessons days, as well as there will be a period called IA days. So on IA days, you have to come back and you go to the lab and collect your data. Okay, and so you have to finish your data collection by term 4, week 8. And then again, you have 3 weeks like that of report writing, just like your group A, you have 3 weeks for report writing. Finish up the report writing in 3 weeks and then submit your IA draft by term 4, week 11. Okay, so everything, both group A and group B, you submit your IA draft by end of term, by 2026. So for group A, we'll be submitting around week 6. For group B, is submitting about week 11. All right. Then over the holidays, the teacher will be able to mark and give you a good feedback because we can only mark one draft. So we want to give you a good feedback and come back January. We'll meet every student to go through your feedback so that you can touch up early and submit by term 2, week 5. That's the final IB submission, term 2, week 5 in year 6. Now, that period, although it looks very long, but many students still cannot cope because of quota management. That is one. Second is that there's a lot of other submission ongoing, ME, TOK, BM, Econs, there's many other submission ongoing. But no matter what, please keep this deadline. Term 2, week 5 is a final submission. And also that period will be a busy period for some of you. You have your SYF, FOA, you have your NSG, okay? And so therefore, if you try to keep to our timeline, that will give you a better chance of you being able to cope well. Okay, so if draft isn't that perfect, you will still have time to do a touch-up for the final submission. Okay? So take notes of most important date. If I tell you too many things, you also will not be able to remember. So just remember the first two dates in red, 12th of May, 3rd of August. For Group A, not 12th of May, 17th of May for Group A. For Group B, 3rd of August, okay? That is to submit the proposal to me. And for submitting the chemical requisition to the lab, it's an online requisition form that you have to fill in. For Group A by 27th of May, by Group B by 17th of August. Okay? That will be quite safe for you so that you can also focus on promotional exam. So data collection for Group A will be immediately after you come back from June holidays. And for Group B will be immediately after promotional exam is over, the regular lessons time, and also IA days to come back to school. All right, so so you can see based on the timeline, whether you are Group A or Group B, you will submit your draft by this year, okay, by different weeks, and such that next year you can meet your teacher for feedback, and final submission is the same date for everyone. Okay. All right, so later I will go through with you the different forms. I've touched up a little bit. I make my own Form A, so it's easier, I feel, for you to use my Form A. So that is, it will guide you along the way to your draft writing anyway. And then there's some checklist. At this point, maybe not that crucial for you, but more important will be the Form A and also the lab inventory. You need to know what is available in the lab. And in the event you need to buy anything, then you need to use number 5, which is on the IA channel of the cohorts teams. Okay, so there will be a document, which is the lab inventory, which is item number 4. So you need to at least open up item number 4 so you know what is available in the lab in order for you to come up with a proposal. Okay, so this is how the inventory look like. It's an Excel sheet, looks so scary and complicated, but don't worry. Okay, so there are different tabs, so you just look out for what you want. So if we are looking out for things like glassware, so go to the first tab, you see what are the glassware available and their uncertainty and their volumes. So when you plan your procedure, you fit it according to what is available in the lab. Second, equipment. Some people want some pH meter, some people want some checker, some people want UV lamp. So therefore, you are allowed to check against the list to check what you want is available. Do not Teams me to ask me, do we have water bath? Do we have this chemical? Do we have iron chloride? You will check through the Excel list. Understand, I will not entertain this type of question. You will search the list. And the uncertainty of the equipment and some specifications are here. So for chemicals, if it's a liquid, that means it's concentrated or certain concentration is stated. So you look carefully. So if no concentration is stated, then it's taken as 100% pure. But if concentration is stated like that, this one 2M, 6M, and then things like 2M, 6M, 8M, 12M, that means it will be available in this concentration. If you want something else, you will have to dilute and prepare. Okay, if what you want isn't all this concentration here, we will still give you what we have and you do your dilution and preparation. Now, most of the chemicals are in solid state. That's why it can last. So if you want certain thing, copper sulfate, do we have? Then you go to this table and check. Okay, if I say iron chloride do we have, then you go to this table and check. Understand? Now, this table is really very important. Listen, you are not going to use your own formula. So you're not, let's say copper chloride, you're not going to use CuCl2 and the MR of CuCl2 to do it. You will look at the MR here, CuCl2 2H2O. So you will factor in the 2H2O in your calculation. Okay, let me illustrate again. So let's say you want FeSO4. You do not take a periodic table and calculate FeSO4MR. You have to calculate FeSO4 7H2OMR. Okay, because the thing comes with water. So you have to calculate based on what the chemicals are existed in the lab, how they existed, and use the MR. So if there's water of crystallization, it has to be factored into the calculation as the total MR when you calculate the mass needed. Okay, now you can find that there's some hazards here. It's just to keep you aware so that you handle them with care, but you do not copy and paste this line or this into your own IA report because it will be flagged out as plagiarism. All right, this part here is to give you some idea of what are the risks when you are handling the thing. But if you want to write on the safety, you have to write in your own words or you have to cite references. The references is not the inventory list. Okay, the references will be some like online sources. So these are some of the apparatus, other apparatus that we may have that you may want to use. So we put it here for you to have some understanding and the indicators available. Okay, so you search through the whole list to find what you need first to make sure that what you're using is available. All right, okay, so now IB has this allowed the use of carcinogenic chemicals, so we will not allow students to access cobalt, nickel, lead, dichloromethane, and other chemicals which are hazardous. All right, so certain chemicals you may need to pay if the chemicals are very costly. A lab tech will advise you that if payment is needed or to top up for the cost. Now, and if you need a new chemicals that is not in those lists, then you will have to make a payment for it. Let's say you need a certain chemicals and you want to order it, then you will have to make a payment for it. Now, I will usually advise not to buy any chemicals. I will advise you to try to use what you have in the lab for IA. Okay, the reason is because the delivery is really very long and you really don't want to be held up by that. So it will be better for you to use common chemicals for IA because remember, IA requirement is not like EE. So it will be better for you to use the common chemicals and then vary how you write and how you investigate. Okay? But in the event, if you really, really want to buy, you can do so, but just take note that you have to fill up one more form to buy chemicals, and the delivery is about at least 2 to 3 weeks at least, and it can be quite costly. Okay, collaboration work. Now, although IB allows collaboration work, you'll find that the type of collaboration they allow is really quite limited. So you can form your groups, but in the end, right, everyone must have a different independent variable. Everyone cannot be like investigating the same research question, and you are not allowed to share data. So because by right, you are looking at a different independent variable or you are measuring a different dependent variable, in a way, you will not be sharing data. So the collaborative work is just like a pair of hands to help you hold something. At the end of the day, everyone has to collect your own data, no sharing. And therefore, I would strongly discourage collaborative work. Because if you do collaborate with your friends, sometimes it's inevitable that the way you write is very similar to the way your friends write. And then that becomes an issue. So I would still tell you, as much as possible, do it on your own. Because you can't share data anyway, and you really cannot share the procedures also. You cannot have both persons having the same procedures. Because your dependent variable should be a bit different. Your independent variable should be a bit different. You can't be the same in the group. So therefore, try to do it individually. All right, because if not, right, if there's a incident of like both reports or both data or both procedures are too similar, then it's a bit problematic to handle. Okay, so stay as individual. It will be the best for you. Okay, so you see here, they mentioned that if you are in a group, you must have a different independent variable. You can have the same independent, but then you must have a different dependent. So basically, to summarize, you must have a different data. So must as well do it on your own then, okay? Okay, so I will not go through this. Okay, so I will go through the research questions. So the research question should have the independent variable, dependent variable, and the method. Okay, and what is the variation of the independent variable? At least you should vary it, if possible, 5 times. So let's say if you are looking at how does temperature affect something, then try to have 5 variations of temperature. How does pH affect something? Then try to vary pH 5 times. Dependent variable is what you measure. So let's say you measure how the amount of vitamin C, the amount of calcium, the amount of EDTA needed. That's your dependent variable. Method, whether you're doing titration, whether you are using spectroscopy, whether you are using a calorimetry, measuring the energy change, temperature change. So the methodology. So basically, the complexity cannot be too complex. It has to be something that is finishable or can be completed. You can finish it in 10 to 12 hours. Really, you have to finish it in 10 to 12 hours, including preparing the chemicals yourself. So remember, everything is given to you in form of salt. So if you want 0.5 m iron chloride, so you will go and weigh out and then do your calculation, resolve, form the solution. So we try not to be super complex until you cannot even finish it. All right, you have to finish within the weeks given. Okay, do not do brand analysis. I mentioned 1 million times already. Do not go and look at different milk and tell me which brand of milk is the best. Do not look at different fruits and tell me which one has more vitamin C. You have nothing to write at the end of the day. You can finish the experiment, you can collect data, but you have no discussion. You will not be able to write a conclusion that is chemistry based. And so therefore you may lose heavily on one aspect. So these are some of the topics that we will cover. Okay, you have done kinetics, there will be some energetics, you will look at enthalpy change. There's a lot of mole titration that you have done. So you can do acid bases. So these are some of the topics that you can arrange your research to be on. Do not need to go beyond the syllabus for IA. Stay within the syllabus. It will help. All right. Okay, so you can refer back to our IAs that we have done in the past, and then not in the past. So the IA we have done, and then get your inspiration. But you're not limited to what we have done. If you really can find something online and that thing is doable, manageable in 10 hours, you can go ahead and do it. Okay, so example of research question, investigate the change in iron content in avocados with different storage condition, different stage of ripening, but different stage of ripening is not good. Try not to write, or subject to different amount of heat. Okay, investigate which catalyst is the best, is the most effective in increasing rate of reaction. All right, and compare a few oxidant and see which one is the best at oxidizing something. Okay, and then how does pH affects the degradation of certain chemicals with time? So you adjust the pH and see how the chemicals degrade, and you measure the remaining amount of the chemicals. Okay, you can also find enthalpy change, find out how much heat is given out during the reaction as you carry out an enthalpy change of reaction. You can also find out dissolved oxygen in water under different conditions. You can also carry out experiment to find out the rate equation. Or you can find experiment whereby you already know the rate equation, and then applying that rate equation, you already know, find the Arrhenius constant activation energy. That one is really very tedious. Okay? So if possible, just stick to titration, which is more manageable. Kinetics is possible for order of reaction, for activation energy, but it's going to be tedious. All right? Equilibrium constant, you can do some experiment which is reversible, and you monitor and you find out how equilibrium constant changes with temperature, or you find if equilibrium constant changes with pH, or you can find out the equilibrium constant for the reaction, and then you comment on it. All right. We try not to do an experiment that find a number. So example like this, find an equilibrium constant number on its own itself, as you don't have much things to talk about. But if you say that I want to find out how equilibrium constant value changes with temperature, so there's a change in temperature and so the value changes, then you have a trend to talk about. So at the end of the day, what we want is that it's safer to do a topic that has trend. Okay, so if you tell me I want to find the order of a reaction with respect to HCl, so after you finish the experiment, the order is 1. So what can you say? The order is 1. So your discussion will be just keep telling me the order is 1. Then you find that you are very stuck. In a way, you cannot present a lot of ideas. You'll not be able to elaborate the discussion. So it will be better to have something that you can vary the independent variable, and you measure the dependent variable. So we want to establish some trends. Is there some trend? And then if there is some trend, then we can explain the trend. And find that there's no trend, then we can also explain why there is no trend. So you'll find that this type of topic, you will be able to develop better in the discussion than to come back with an answer, Kc is 100. The order is 2. It is not impossible to do those, but just that you must be able to discuss extensively either how you process the data or other aspects, so that the discussion will also be rich. Okay? And I will go through how to fill up the proposal form now. I will not use this. I will make use of my own Form A. So I have my Form A here. Okay, I will bring you through and I will send you this Form A. Now, there is no page limit, but there is a word limit. All right, so just take note, the whole IA is 3,000 words. And that includes your introduction, background, procedures, your data processing, and your conclusion, evaluation. So from my past experience, students do not leave enough words for conclusion and evaluation. So therefore, for this batch, I want to implement you some guidelines. So your intro, your background, your procedure should not be more than 1,000 words, if possible, so that we can keep at least 1,600 words for later when we do the conclusion and evaluation. So I'm going to reserve these words first for these 2 sections. Data processing, those mathematical calculations are not in the word count. We are not in the word count, so I'm only reserving lesser words for this, about 400 to some describe the trends, describe the graph, and describe the colors. Okay? So for the proposal stage, you are focusing mainly on intro, background, procedure. So maybe we look at about 1,000 words, at most 1,001, 1,002. So anything that you exceed, you are taking from other areas. So that means other areas will be short of word count later. So we try to balance. Now, as you do the proposal, do not use the AI. Now, really don't use the AI, because if you use any AI, you have to cite the AI with the prompts that you use. So you not only cite it in the text, you have to cite it with the prompts that you give to ChatGPT or etc. And after you cite, right, that part, right, will not be taken as your work, and it will not be awarded any marks. All right. So Anything you use AI, you cite, is good because it is academic practice to cite, but those will not be awarded as marks because they are not your work. Then you will say that, okay, then I don't cite is better. No, because if you don't cite, then it's an academic honesty issue. And for IIB, they would factor academic honesty quite strictly. And so you will lose your diploma if you found that the work is not your work and you did not cite. So therefore, if you look at this, the best way is don't use AI. Okay, you can use the AI only for brainstorming, and you can use AI to research, but the writing has to be done by you. You have to be the one writing it. You have to phrase it. You have to maybe just bounce off some ideas when you're forming off the research question. But eventually, you must be the author. Most of the ideas must be from you. All right, so you are supposed to type your research question in, okay, onto this form, which is your proposal form that you have to submit to me. Okay, and then I will guide you what are the areas that you have to write. So introduction, only very brief. Give me a very, very brief relevant context of your experiment. Okay, and like where, if you ever find any conclusion, where would you apply it? And then state the research question. Then under background, you will go a bit longer. Okay, it can be about 1.5 pages. It will talk about the chemical equations, the background of some of the chemicals used, the chemical structures, any reaction mechanism, any reaction equation. You will explain some of the scientific knowledge that is relevant to your research question. It has to be relevant to the research question. Okay? So it cannot be something that is like very generalized. It has to be specific. Okay, it has to be specific. It's not even relevant. It's specific to your research question so that the reader can understand the process, the chemistry behind. Okay, what have you gathered a little bit from literature research? What has been known? What has been done? Just a bit of it. Okay, so as you consider your method, you want to do titration, you want to do spectroscopy, you want to do certain method, you consider what are some of the methods that you can explore to address that research question, and then explain why do you choose that certain method. Okay, provide some background of the method used. So if it's a method, it's an acid-base titration, then provide some background of acid-base titration. If the method used is spectroscopy, provide a bit background of spectroscopy. Okay, so if the background method used is EDTA titration, provide a little bit background of EDTA titration. All the structures, chemicals, pictures must be captions and labeled nicely. If there's any personal input that you have made to the method, that means you have made some adjustment because it's not available in the lab, because you don't want to use so much chemicals, so you choose to dilute it, to use lower concentration to reduce chemical waste. All these type of personal input will have to be reflected and stated clearly. All right. Because that will also help you to impress your marker a bit. So the structures must be labeled with captions, okay? Anything on the background, because most probably when you talk about some background like EDTA titration, when you talk about this chemical, when you talk about UV spectroscopy, when you talk about calorimetry, when you talk about what is a catalyst, when you talk about activation energy, these are not your work. These are usually common knowledge, or these are things that you found from the internet, the background information. So you will have to cite in text citation. Okay, you have to acknowledge the work of others or where you get the information from. So you must cite in text citation. Then sometimes you may want to come up with a hypothesis. Example, if you're investigating how does pH affect something, then your hypothesis, you state your hypothesis with reasons. If you cannot give me a reason, then don't include a hypothesis. You include a hypothesis, you must give me a sound, logical, scientific reason, just a few short lines of scientific reasons to support. So you say that, oh, I think the activation energy will decrease because as more catalyst is added, blah, 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 blah. Okay, so you need to have some logic there behind your hypothesis. Even if it's wrong, it's fine. Even if your hypothesis turned out to be wrong or different, it's fine. But you cannot just say, I think it will increase. That full stop. But don't know why. You didn't explain why you think that way. Okay, so basically you can say, I think it will increase, decrease, any trend that you like, but you must have some reasons. Okay, the chemical and apparatus list. So you list out all the chemicals that you're using, the concentrations that you're using, the quantities you're using. Use the IUPAC name for the chemicals, not ferric, ferrous, cupric. Okay, key in the glassware, volumetric flask, how many ml, pipette, how many ml, urette, how many ml, and the uncertainty. So uncertainty is in the Excel sheet. These are all the equipment. If you use pH meter, what's the uncertainty? You use a thermometer, what's the uncertainty? You use an oven, what's the uncertainty? Okay, then you have a table of variables. So you will list out what is your independent variable, how you will vary to get the values, and what is the range that you're going to look at, and what is the interval? Is it, if I'm going to look at temperature, what is the range I'm going to look at? Is it from 20 to 80 or is it 20 to 100? And the intervals, am I going to go at 5 degrees interval, 25, 20, 25, 30, 35, or I'm going at a bigger interval because of a particular reason? Then you say, I will do 20, 30, 40, 50. So you need to state the interval and why do you choose that and how many of variation. So by right should be at least 5. Okay, if possible. Then state the dependent variable, what you're going to measure. Oh, I want to measure the amount of vitamin C left. Okay, then how will you measure the amount of vitamin C left? I will measure by thiosulfate titration, find out how much thiosulfate, and then I will repeat how many times and average consistent result. So you need to state how you get the dependent variable. What are some of the things that you will control? Or I will control the amount of indicator added. I will control the amount of sample pipetted. I will control the amount of vitamin C volume heated. I will control how long I will heat. So what are some of the controls that you need to control them? And how are you going to control and why do you need to control them? Okay? So take note, temperature control by air conditioner is not accepted. Is not accepted. So no matter what, you just write down, I use a water bath. All right, just state water bath or hot plate. Okay, so I'll give you some idea how it looks like because some of you are very lost already. So you will write a report that like this. Okay, example, come up with a research question, and then some short introduction, not too long. And then background information must be related to what you are doing. Put in some pictures and then put down some captions. If there's a chemical, put in some chemical equations, talk about the chemical nature or whatever they are doing. If then you are looking at the methodology, if you're talking certain methodology, then state what is a little bit of background of the methodology. Keep to 2-page max only. Okay, if you are writing too long, then you will use a lot of word count. Then there's the chemical list. So list out what are the chemicals you are using, what's the concentration, how many grams are you using, etc. The table of variables. What are some of the things that you must keep constant? Why? How are you going to keep constant? Why you must keep constant? If you don't keep constant, what will happen to the result? Okay? And then state what is your independent variable, the pH. I will measure how you varying it. I will adjust using a buffer. This is not a good example because the person didn't put down the range. So you follow my form. Okay? Dependent variable, what's the what you measuring? For measuring the absorbance to find out the final concentration. So you will state how are you going to measure your dependent variable, etc. Okay, so now back to that form. Back to that form. So I'm already brought you to here. So pre-trials, this section cannot be filled in until you have tested your experiment. Then after you test your experiment, maybe you learn something and then you tweak your procedure or you make some adjustments. So you put that under pre-trial. Okay, so procedures. Procedures is very, very long. You can subdivide into separate sections for different segment of your experiment. You have to write very details on what to do, including preparation of reagent. Procedures ideally to be written in past tense. Tell me how much to use, and also do consider to reduce the amount that you use during planning. Don't use so much, so concentrated. Try to use smaller volumes and lower concentration to conserve chemical, to reduce chemical waste. Include absolute uncertainty of any equipment that you use in a procedure. Do more calculation and show me the workings. Okay, you will not understand what I'm saying. Later, I'll show you examples. So include the mass of the reagent, the apparatus you are using, the beaker, what is the size of the beaker. All solution has to be prepared using volumetric flask. So you don't tell me I'm going to pour that into a beaker and shake and that's it. No, everything must be prepared using volumetric flask for solutions. Use IUPAC name in your writing. Highlight any personal adjustment that you make after your initial trials. But now you couldn't write this, but next time you can. Okay, include the controls within the procedure also, or keep the temperature at plus minus 40 degrees. Measure 10 minutes, heat it for 10 minutes, or stir for 2 minutes. So all these are the relevant control that I can find in the procedures. Remember, temperature control by aircon is not allowed, so always state water bath or hot plate. Okay, procedures must be very clear so that anyone who take this set can repeat it in the lab. There must be 5 repeats ideally, okay, and a range of independent variable. So whether it's 5 or 3, it depends on the difficulty of the experiment. How many repeats? Okay, so I show you an example, then you can understand better. So look at this. All right, so the person is writing procedure, right? So see, she divided into different segment of the procedure, preparing this, standardizing this, preparing this, then determine the mass by titration, etc. So can you see next thing is that she also include the mole calculation. So when she say, and the quantity, so 0.79, I know why 0.79, because I can see that is calculated here. Okay, look at the apparatus. They do not just say dissolve in volumetric flask, they say dissolve in 500 ml volumetric flask. So it must be so clear that the person reading it, bring this paper, will be able to do. So 0.1 oxalate, blah, 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 dissolve in how much water in what size volumetric flask, talk to the mark, shake well. Okay, then add how much? Add 25 ml sulfuric acid, blah, blah, blah. And even tell me what to use to measure the 25 ml. So you can say use a measuring cylinder. Okay, these are things that you can write. Of course, other ways that you write is you can also write in this manner. You put in the uncertainty with the values also can. All right, you can put in the uncertainties with the value. You can present some tables form. Okay, and then you give out very clear procedure, how much to prepare into how much, what is the flask, and then how much, what do I add? I add water. I need to shake 3 times, 5 times, homogeneous. All right. And then if I do a spectroscopy, what is the wavelength? What is my blank? All right. Everything is stated very clearly. Okay. So even if you stir, how much was the stirring? Stir for how long? All right, all this information should be reflected in the Form A. All right, then one last paragraph on safety, environmental disposal, how you dispose your chemicals, ethical considerations. All right, so you can talk about some of the risks involving the chemicals, the risk involving the instruments, such as you are using a hot plate, it's hot, the risk involving the procedure. Okay, maybe the procedure is it shines UV light, So there's a risk exposing yourself to UV light. Okay, so and so on. So what are the appropriate protection equipment? Wear goggles, wear gloves, put on lab coat. What do you do with the chemicals after you finish? Where do you throw them? How do you throw them? Why you just cannot anyhow throw them? You must, okay, so you have to state very clearly how, okay, do not tell me the lab tech throw away for you. Just so you have to tell me dilute, neutralize, uh, pour it into chemical waste container, why, etc. Okay, so this is a short segment. So if you go back to the report, what do I mean by a short segment? Something like this, one small paragraph here. Okay, or you can look at this, just a small paragraph on safety, protective goggles, burns, ethical considerations, food waste, what do you do? So you dilute it, blah, blah, blah. Okay, so your proposal will stop after you finish the safety and the bibliography or your reference. So anything that was used in the creation of your proposal or reference in the creation of proposal should be cited and included in the bibliography. So everyone, please use my Form A. So I have all the guiding parts inside the form so that you will not tell me I didn't read, or you will not give me other work that I will not even want to read because you didn't follow the guidelines. Okay, my guidelines is to make your life easier later. So if you do it now, when it comes to the draft, it will be easier. If you come to the final, it will be easier. Okay, it's painful now. It's quite painful now. I understand it's a lot of work to do, but it will help you later. Okay, so I will stop here. And further discussion will be back when we are in class face to face.